When you hear AI agent, you probably picture a chatbot, right? Just sitting there in a window waiting for you to type something. But what if that whole idea is completely backwards? Today, we're diving into OpenFang, a project that flips the script. It's not about building agents that wait for you. It's about agents that work for you, all on their own. This quote from the project's own docs, it nails it. This is about a massive shift from being reactive to being proactive. So forget about the tool you have to constantly poke and prod. Imagine instead an autonomous coworker that's on the job 24/7. That's the future OpenFang is trying to build. So here's our game plan. First, we're going to unpack why this is an agent OS and not just another framework. Then we'll get into the really cool part, the autonomous hands. After that, we'll check out the universal connector that makes everything talk to each other, see how it all works in a real-world workflow, and then we'll wrap up with an honest look at where the project is today. All right, let's jump into section 1. The folks behind OpenFang are really clear on this point. This is not just another chatbot framework. They call it an agent operating system. So what does that even mean? What's the real difference here? Let's break it down. This slide really lays it all out. On the left, you've got the world we know, the reactive chatbot. It just waits for your input, and it's often just a simple Python wrapper around an API. But on the right, you see the agent OS model. It's proactive. It runs 24/7 on schedules you set, and it's a complete system built from the ground up in the super performant language Rust. And the real beauty of building this in Rust? It all boils down to this. 1. The entire powerful system compiles down to a single binary file. That means no messing with complex dependencies, no virtual environments, none of that headache. You just download it and run it. It is literally that simple. And get this, that single file is tiny, just around 32 megabytes. Think about that for a second. In a world where AI tools can be massively bloated, this focus on efficiency is a huge deal. It's so lean it can run almost anywhere without bogging things down. And just to put that size into perspective, let's look at the numbers from their public repos. OpenFang is just a sliver compared to some of the other players. We're talking 32 megs for OpenFang versus 200 for AutoGen and a whopping 500 for OpenClaw. It's not even a competition. They're playing a totally different game. Okay, so we've established it has this lean, super efficient brain. But what about the muscle? What actually does the work? Well, that brings us to section 2, and what is really the core innovation of the whole system, this concept they call hands. So what exactly are hands? This is the feature that really delivers on that promise of being proactive. Hands aren't just functions you call. They are these self-contained, autonomous packages of capability. They're built to handle complex tasks all on their own, on a schedule you decide, without you ever having to tell them to start. And a hand is way more than just a simple script. Each one is actually a pretty sophisticated little package. You've got a manifest file, a system prompt, which the docs call a 500-plus word expert procedure, a file for its specific domain knowledge, and, this is critical, built-in safety guardrails with approval gates. Okay, this is where it gets really exciting. Just look at what some of these hands can actually do. The researcher hand can autonomously dig into topics, cross-reference sources, and write up cited reports for you. The collector acts like your personal intelligence analyst, constantly monitoring a topic for updates. And my favorite, Clip, can take a YouTube URL, find the best moments, and automatically chop them up into captioned vertical shorts. These are real high-value workflows, completely automated. All right, so we have these powerful autonomous agents. But that's only half the story, right? How do they connect to the rest of the world? And just as importantly, how do we connect to them? That brings us to section 3, this universal connector they call the Model Context Protocol, or MCP for short. This really gets to the heart of a huge problem in the AI space, interoperability. You've got your agents running inside OpenFang. You've got external tools like GitHub or your file system. And then you have your most important tool, your code editor. How in the world do you get all of them to speak the same language? Well, the answer is MCP. The easiest way to think about it is like a universal translator for AI applications. It's a standardized protocol that lets any app discover what tools another app has and then use them in a simple, predictable way. It's the lingua franca that lets this whole ecosystem talk to itself. And the way OpenFang uses it is a two-way street, which is key. First, it acts as an MCP client. This means you can point it at your other tools, your file system, web browser, whatever. Once you've made that connection one time, every single agent inside OpenFang can now use those external tools. You configure it once, and it works everywhere. But here's the other side of that coin, and honestly, this is the real game changer. OpenFang also acts as an MCP server. This means it exposes its own powerful agents, like that researcher hand we saw, as tools that other programs can call. So now your IDE, whether it's VS Code or something else, can directly talk to your autonomous agents. This is a huge deal for integrating AI into a developer's actual daily workflow. Okay, that's enough theory. What does this actually look like when the rubber meets the road? Section 4 is all about putting this to work. How would you actually set this up and use it day to day? Well, getting started is shockingly simple. I mean, look at this. It's 3 commands in your terminal, one to download and install, one to set up your config file, and one to start the background process. That's it. You're up and running. Now, here's the piece that connects the dots. This is an actual config snippet from the docs. All you do is add this little entry to your IDE's configuration file, telling it how to launch the OpenFang MCP server. This one line is the bridge between your editor and your agents. And this is the payoff. Once that connection is made, you can be sitting in your editor, looking at your code, and you just type a prompt like this. You're not asking the built-in AI for a simple suggestion. You are commanding a specialized, powerful, autonomous agent running an OpenFang to go perform a complex task for you. That is a developer workflow superpower. Okay, this all sounds incredible, but let's wrap up with our final section and get real for a moment. It's really important to understand where a project like this is in its development journey to set the right expectations. And I've got to say, I really respect how transparent they are in their README file. They state very clearly that, as of early 2026, the project is pre-1.0. The core is solid, but you should expect things to change and maybe even break between updates. Their official recommendation? If you use this for anything serious, pin your version to a specific commit. And just to double-click on that solid core idea, this language breakdown from their GitHub repo says it all. At over 88% Rust, you can see this thing is purpose-built for performance, safety, and security. This is what allows for that tiny install size and gives you confidence that it's on a solid path to version 1.0. So what's the big takeaway here? It's that this shift from reactive chatbots to proactive autonomous agents, it's not some far-off future concept. It is happening right now, in the open, with projects like OpenFang. The tools are here. So the only real question left is the one on the screen. How are you going to put them to work?